Alright, hey guys, how's it going? Today we're going to be talking about units and we're looking at how to figure out what the givens are in a problem. So let's get started with units. So units for the kinematic problems. So the units that we'd be using mostly are going to be distance and displacement. We're always going to be looking at meters, right? Represented by that little m there. Speed and velocity, meters per second. And then this is meters divided by seconds, meters per second. Acceleration, it's going to be meters per second, also known as meters per second squared, right? It's the velocity every second. So meters per second, which was our velocity, every second, per second. So meters per second squared. Then we've got time, which is in seconds. Which you guys should already know that one. So let's get started on a problem. Let's look at it. Alright guys, so we need to figure out what the givens and the unknown are in this problem. Okay, so first thing we need to do is look at the units. We just looked at units a second ago. Units are going to be the single most important thing that's going to tell you what you're looking for. So in this first one, we've got Georgia is jogging with a velocity of 4 meters per second when she accelerates at 2 meters per second squared for 3 seconds. So for the givens, we know that she's jogging with a velocity of 40 meters per second and she accelerates. Okay, so that means that we know that her initial velocity is 4 meters per second. Because of the units, and it also says velocity, we know that this is velocity. How do we know it's initial? Because she's accelerating and it's asking how fast she's going to be running now. So we know that they're looking for final velocity. So we know our initial velocity is 4 meters per second. Next, we know that she accelerates at 2 meters per second squared because of the units, and it also says acceleration. So we know acceleration is 2 meters per second squared. Finally, it gives us 3 seconds. You should know that the unit for time is seconds, so we have time as well. And then to find the unknown, we usually look to the question that's usually at the bottom. So how fast is Georgia running now? What is her velocity now? What is her final velocity? So that is how we find the givens and the unknown for a problem. Next, if we got a bullet that leaves the muzzle of a rifle at 600 meters per second and the barrel is 0.9 meters long, what was the acceleration of the bullet while in the barrel? So the givens, let's look at what we've got first in the problem. We've got bullet leaves the muzzle of a rifle at 600 meters per second. Okay, so this is a tough one because we know that the bullet stopped, right? We need to know about the entirety of the problem. So we need to know everything that it's asking. So it's asking what is the acceleration of the bullet while in the barrel. So we're looking, this whole thing is happening inside the barrel. So if the bullet leaves the barrel at 600 meters per second, then it must have started in the barrel at 0 meters per second. So its initial velocity is 0. But its final velocity then, because we have meters per second, we're looking at that unit, its final velocity is 600 meters per second. It gives us displacement. So the displacement is 0.9 meters per second. And then the initial velocity, because remember we're looking inside the barrel, everything that's happening inside the barrel, so the bullet was at rest. And then it got shot out, and when it left the muzzle, when it left the barrel, it was at 600 meters per second. So it went from 0 to 600 just in that barrel, right? And it's asking what was the acceleration of the bullet while in the barrel. So the unknown is acceleration. So let's look at the givens first. So a car slows from 22 meters per second to 3 meters per second. So we know because of meters per second, these are our velocities, but we need to know which one's initial and what's final. Well, if it slows from this to this, we've got initial to final. So our initial velocity is 22 meters per second, and our final velocity is 3 meters per second at a constant rate of 2.1 meters per second squared. It doesn't tell us anywhere that it's acceleration. We have to know that because of the units. So again, it's really important that you guys know these units. So the acceleration is 2.1 meters per second squared, and then they're trying to throw you off here. They gave you this other number again, 3 meters per second, to try and confuse you. Okay? How many seconds, so it's asking for seconds, time, are required before the car is traveling at 3 meters per second. So they're just restating the final velocity. This number is not important. Okay? They're just restating that final velocity. So what we need to look at is how many seconds. So we're looking for time. So our unknown is going to be time. So this is how you get the unknowns and the givens for these types of problems. Hopefully that helped you understand it a little bit better when we go in depth together. So again, this is Mr. Black signing off.